Hi everyone, hope you are all doing great. Today we are gonna see the OTP module called GenServer and see some advices about how we can empower our Elixir application using this great OTP stuff. A GenServer is a module for implementing the server part of a client-server relation. We can see a GenServer like a behavior module for implementing the server of a client-server relation. Also, a GenServer acts like a web server, so it listens for requests and can respond with a result. GenServer also provides a robust framework for creating server processes that handle the requests from multiple clients and manage concurrent interactions, processing incoming messages and response to clients. In a GenServer, we can store state and build complex logic. We can maintain internal states, allowing the implementation of complex business logic, making them versatile for building sophisticated long-running services. We can also say that Tune servers act as stateful containers with customizable behavior, combining persistence data storage with flexible message handling. Tune servers provide a set of callbacks available to implement. Among others, we can have the handle cast to execute async logic. We can have the handle call to execute sync logic, and also handle continue to defer the initialization of the state of the server, among other callbacks. We need to say that we only require to implement the callbacks and functionality that we are interested in and just leave the others unimplemented. We also need to know that a GenServer can attend one message at a time. So GenServers are processes that under the hood are just mailboxes. So a GenServer will process a message when this arrives, but if a second message arrives when the GenServer is still working, then this message will be moved to the process mailbox. Since GenServer are processes, there are some points that it is good to clarify. A process can only make two actions: run code or wait for a message to arrive. A process will always be sequential. This means that a single process can attend one message at a time, and this means that if a single process receives several messages at the same time, then that process can be a potential bottleneck for our applications. Also, if messages arrive faster than the process can handle, this will lead to issues in the program throughput. Lastly, we need to mention that processes are executed on the Great Erlang virtual machine. So the Erlang virtual machine will have as many schedulers as CPU cores we have available in our hardware. The scheduler gives a slice of time for each process to execute, and when this time elapses, the process will go back to the queue and wait its turn to be executed again. This will be repeated as many times as needed until the process finishes the execution without blocking other processes indefinitely, also preventing them from monopolizing the resources. This is called preemptive scheduling and is the reason why Beam can run under very high loads without crumbling. Okay, that being said, let's see some code. Here is a possible use case of a shell server. Imagine that we are building a payment application that enables us to send money between users, and we need to find a place to store all the possible currencies that our application can handle. So one possibility is to use a Shen server to store a list of currencies. So here we have our module called currencies store. In this line, we can use the statement of use Shen server. So what is doing this for us? This is adding the child spec function. So this module, this Shen server, can be added as a child of our application supervisor And also the use GenServer is injecting under the hood the behavior of a GenServer, so we have the functionality and the callbacks available for us to use in this module. Then we can divide the GenServer in two parts, as we previously saw in the slides. We have the client part of the GenServer, also can be seen as the public API function, and then we have the server part or the internal callbacks function. Something that we need to take into account and also understand is that the clients that will be making communication to our Shem server are just other Elixir processes. So we can just see the Shem server like a current web server in which we are going to have different clients sending requests to our server. This is the Shem server, and the server will be return back a response. In the client part, we can see the startling function, the one that will be creating this process. This GenServer will have as the initial state an empty list of currencies. After that, we can give a name to the GenServer. In this case, will be the name as the current module, and then we can just call the GenServer.startLink. Then we are gonna have two public functions, two functions that can be called from outside of the GenServer. This will be add element to add a new currency in our GenServer and will be handled by the handle cast function of the GenServer. And then we have the get element function, the one that will be retrieving the state of the GenServer and will be handled by the handle call. On the other side, we can see the functions that will be part of the internal server. In this case, we have the init function. We are not providing any other state, so will be an empty list. And then we have the two callbacks. The first one will be the handle cast. In this case, we can see that the handle cast will add a new element in a list and update that new state. And then the handle call will allow us to get the element from the state. So with the get element, we are gonna retrieve the list of the currencies that our application can handle. So let's give this GenServer a try. We need to first add this GenServer as a child of our application supervisor. And right after, we are gonna start the IX console and copy and paste the module name. So here we can execute the get element function. In this case, since the state of the GenServer is just an empty list, there is no currencies yet, so we can just go here and add new currencies. Let's say that we add two currencies to our GenServer state, and if we execute the get element, we can see that in the state we have a list of two currencies. This is a very simple case of a GenServer, but is good enough to store state and retrieve that state. Sometimes when we work with GenServer, we are gonna have the need to start a GenServer with an initial state with some values. In this case, we have an empty list, but let's say that we wanna need to go to a database to retrieve some information or make an external API call to retrieve the currencies of our application, and imagine that the logic that we need to add will take some time, for example, 4 seconds. For that, we have this function called heavy operation. This will just simulate that this operation will take 4 seconds, and after we are gonna just return a list of 3 currencies. So we are gonna see what happened if in the initialization of our shell server we add that heavy operation, the one that will be take 4 seconds. So we are gonna start our shell server, and in the console we can see that this is doing that heavy operation. This will take 4 seconds, and right after we are gonna return the control to the client. And obviously this is not a good design to add to our share server because we are gonna be blocking the client. If we are working with an agent and we have the same situation, we can create a task and add that heavy operation inside a task, and when this process finish we can backfill the state of the agent. But here with GenServer we have another way of solving this, and is using the handle continue callback. The handle continue callback is a very useful feature that we can have used in GenServer, and we can defer the initialization of the GenServer to other function, avoiding blocking the GenServer. So in this case, we are gonna have this GenServer. This is exactly the same as the previous one, but here in the server part, in the internal callback function, we can see that instead of just returning in the init function the tuple OK state, we are returning a new tuple containing the atom continue and also the function name that we wanna handle in the initialization of the GenServer. Doing this, what we are gonna do is treating the handle continue function, and in this case we can add that heavy logic, that expensive operation that was blocking our client, but this way we are not blocking the client anymore, and we are deferring that heavy logic to be executed with this handle continue. So to use this, we need to again add the GenServer as a child of our supervisor and execute again our application. In this case, in the console, we can see that the handle continue is executing that heavy operation. In this case, simulating that we are making an API call, we are doing that heavy operation and then just returning the state of the GenServer. The big difference here is that the client is not being blocking anymore. Here we can just start the GenServer and continue executing, and the client is not blocked. Then we are going to see that heavy operation is finished.